voice in the background that you're not going to be seeing is Manny Hernandez. We are honored to be joined today by Dr. Richard Jackson. Dr. Jackson is an investigator in the section of Immunobiology. That's a long word. A senior physician, but senior because he's very experienced, not because he's senior. He's the youngest and most amazing doctor you're ever going to hear. And the director of the Hood Center for the Prevention of Childhood Diabetes at Joslin Diabetes Center. He's going to be talking to. He's a lot more things. Actually, he's a former Mary Iacocca Fellow, a recipient of the Cookie Pierce Research Award from the Juvenile Diabetes Research Foundation, and the list goes on and on and on.
Manny, that's very nice. But why don't you start with some questions? Let's just say that you.
We just love you. We just want to, give credit to who credit deserves. All right, so
you're doing this instead of paying me, and that's fine.
All right, so here's what. So we asked Dr. Jackson to join us today to give us a sense of some of the highlights, in his opinion, some of the most important and relevant things that took place at the recent American Diabetes Association scientific session. So these are, and this is an annual conference that takes place every year where, most of the brightest minds in the research and medical field in relation to diabetes meet and share what's going on. So without further ado, one of the first questions, what were the main areas of focus at the conference in your view?
I think one of the things maybe to start is just give people a little background. So I think that often when you have diabetes, you think like, what's happening? There's no progress. Is anyone thinking about me? Are people working on this? And at this meeting, there were 18,000 people, physicians, researchers from around the world. I think this year there were maybe actually a few more international people than from the United States, because this is where everybody comes to see, what's happening, what's new. I think there were like 2,200 different presentations. So on the one hand, that means that there's like a lot of stuff going on. But unfortunately, when there's a lot going on in research and people can be very excited about these areas they're in, if you're sitting outside and you have diabetes, you say, like, how is that helping me? And it's one of the really frustrating things is that the pace of clinical research is really slow. And sometimes it's so slow that we think that, like, nothing's happening at all. And when we think that, I think it's helpful to step back and look, where are we today compared to 10 years ago, 20 years ago. And I know that this long view isn't so helpful for people living in the day-to-day world, but it is notable that people with diabetes really are doing better than they were 10 years ago. So all the numbers that we get show that people with diabetes are living longer lives, that there's less heart disease, less eye disease, kidney disease, everything is dropping dramatically, especially for those people with diabetes who are able to pay some attention to their diabetes and have some support for doing that. And there's lots of variability, but the main message, I think, is that things are really improving, but at a pace that's way too slow for most people. So at these meetings, there can be people who work for years in one area, like the effect of exercise on one aspect of diabetes. And every year, there's new things that help them understand better. And then the question is, does that help us to translate that into something that's clinically useful? And I think that there's little bits of that come out, that although there isn't one really exciting thing, that the addition of all these small things helps people. So one of the things was technology. So Manny, you were there, yes?
I was there, and it is there's so much going on. So yeah.
So what did you think about the new pumps? Did you see like the T-Slim pump?
Yeah, I was very impressed with the array of what just came out from Tandem, and the things coming up in the pipeline with regards to patch pumps. I mean, that seems very exciting as far as like different alternatives for patients to have access to.
Yeah, I think that's one of the things that I'm seeing that may be a smaller thing, but that the pumps have always been, when you look at any other electronic device, pumps seem so kludgy. So I think anyone who sees like the new t:slim pump goes like, oh, that looks like a new piece of technology that you would buy. And I think that people who use diabetes devices should expect the same kind of um, useful interface that people who use other electronic items should have. And like the IBG Star monitor, I thought that that's an idea that people have had for a long time, how to hook a meter up to a pump. And we'll see if it turns out to be useful enough for people to like it. But I think that the fact that they're starting to think of people with diabetes as real people who are consumers who like things that look nice, work well, are easy to use, that's a big change from before when it was like, you have diabetes, you'll have to use one of these things. We don't really have to make them attractive or easy to use. And I think that that's a change I see going back over time. I think that as far as the pumps go, that there were two things that maybe are a little newer. Some people, everybody's wishing a pump could be hooked up to a continuous glucose monitor, and that would work really well. And I think that the main problem there is that the present continuous glucose monitors are still, in general, not quite accurate enough for that to be the case. But there's real improvement there, and I think that that will happen eventually, and I hope it's within a year or so rather than longer. But a couple other things. One is that the pump that cuts off when glucose goes too low, that suspends for 2 hours.
Yep.
I think that that can be very helpful. I think it can be two things. I think it can be very helpful, especially during the night. And not only helpful, but I think it gives a little bit of an increased sense of safety and comfort to those people who either are wearing it or are sleeping next to someone wearing it. Because I know that low glucoses during the night are often a scary thing for both people with diabetes and those who are close to them. And although this is a fairly simple thing, just cutting it off for 2 hours, I think the effects of that might be very helpful for many people. And I think one of the other things that's a little further away for pumps is that when we talk about pumps, we always think about insulin. So insulin, of course, makes glucose go down. But in our bodies, before we got diabetes, we didn't just have insulin that pushed the glucose down. There's another hormone called glucagon that pushes glucose up. And our body uses the two of these to control things into a really narrow range. When people develop type 1 and also in type 2 diabetes, there's problems with the insulin side, but there's also problems with the glucagon side. In type 1, there's not so much glucagon around, and in type 2, there's a little bit too much, and it doesn't act as well as it should at different stages of the disease. So there's now some pumps that are being tested that have glucagon and insulin both in them. And that means that then the pump has two ways to control the glucose, because it can push and pull, and I think that that could make for a safer, more effective glucose control too. That's further away, but the fact that there were a couple different groups, I think that's going to hopefully make a difference sometime in the future also.
So on the technology front, technology that's addressing, the expectations of patients to have devices that don't look as much as devices, but regular, consumer electronics, so to speak, and improvements on the CGM front. Can you elaborate a little bit as to where we are now with regards to CGM accuracy, and what is the outlook of what's being discussed at this point?
Right. So I think that it surprises many people that it's so hard to measure glucose accurately using these indirect devices. There's some other things we measure in medicine. For instance, often in people, especially in the hospital, it's helpful to measure the amount of oxygen in their blood. And that's very easy to do indirectly. And you can be very, very accurate at it. But glucose is, for sort of biochemical and physical reasons, it's much more difficult to get an accurate measurement of it. And I think that there's been a slow incremental improvement. And I was just talking to someone about this. So I see people with diabetes regularly. And I remember when the continuous glucose monitors first came out, I had a reasonable number of people using them. And when people would ask me about them, what do you think? I would say that they were almost useful. And by almost useful, I meant that they were frustrating, they were inaccurate, sort of difficult to use, but some people found them helpful, others were just too frustrated. Now I think I've moved up to saying that they're sometimes useful. When I say that, I think a lot of people would benefit for at least brief periods of use of them, but they're still not so easy to use or so accurate that you tell someone with diabetes, this is what you have to have. But as there's a slow build-up in use of them, that'll bring more people to the market. There's insurance payments for them now. There's other companies interested in this. We're getting close. People can see we're getting close to being able to tie them to a pump, which would be really powerful. And I think all of that's going to increase the rate at which these things improve. I am old enough that I've learned not to say, I think, next year this will work really well. But I think within a couple of years, this is really going to grow and become more useful. And I think, truthfully, that will have a much bigger impact than insulin pumps. I think insulin pumps are a useful choice for many people, but there's hardly anyone that I tell them they should be on an insulin pump. On the other hand, people I see, there's hardly anyone who wants an insulin pump who I don't say, sure, you should try one. But I think if continuous glucose monitors become a little better, that's something that we will be telling everyone with diabetes, this will help you. And it's not going to be a single big breakthrough. I think it's just going to be that the 2 or 3 companies already involved improve their product. There might be a new company that leaps on the market with a different approach that does well. But I think even with the 3 companies that are currently there, that it's really likely that in a couple of years we'll have something that will be really nice. Then we just need to make sure it's available, and so that everyone has access to it.
On that same topic, in regards to CGMs and pumps, and you touched on it briefly, this famous closed loop or artificial pancreas. What did you hear at the conference in terms of where we are with regards to getting there, having a closed loop?
Right. So I think that's still a little ways away, and I have to say I have a little bias against calling it a closed loop system. I know many people do, and many people are calling it an artificial pancreas, but it's not. So, and it only closes half the loop. So, and let me explain this a little. So I'm fortunate. I don't have diabetes. So what my pancreas does is it's constantly sensing my glucose very accurately, and then it spits out insulin into my blood. So when we talk about the closed loop systems, we're talking about, well, if we had a continuous glucose monitor that was really accurate and hooked that up to the pump, that would close the loop. That would work like my pancreas. The problem is that my pancreas doesn't release the insulin into the fatty tissue under my skin, where it can take up to 20 minutes before anything hits and where the effect may last for 4 or 5 hours. My pancreas spits the insulin out right into my blood, where it acts within 2 minutes, and also where it's gone within 5 minutes if I turn it off. So that's a really important other part of the loop. And that's not talked about because the technology on that side, getting insulin into the bloodstream or getting insulin into our body faster, is way behind the glucose sensing part. But for instance, one of the reasons people have trouble with hypoglycemia is because the insulin they took 3 hours ago is still there. If there was a way for the insulin to be there and go away quickly, that would make a big impact. So the closed loop systems are really closing half the loop. Given that, though, they would still be really helpful. But again, the main reason they would be helpful isn't so much that they talk to the pump, although that would be useful for some people, but just having the continuous monitor be accurate would help people, even who choose not to have a pump, to use insulin pens. They would benefit just as much. And the other problem with a closed loop system is if you really turn everything over to the pump and the monitor, that means that they don't have to work, 90% of the time really well. They'd have to work 100% of the time really well. You don't want to be driving down the what's the road out there, the 405 or something, and
Mhm.
have things a little disconnected and go too low. So the safety features of that are going to make it difficult to make it to the final steps. So I think that that's a little further away, but I think that before that hooks up really well, there'll be continuous monitors that are so useful that that in itself will make a really big impact for people on pumps and people not on pumps.
Great, thank you. So let's jump real quick. We've been talking quite a bit about technology for the first part of this interview. So what would you say were the most interesting discussions you heard of in terms of research and actual drugs, either in the pipeline being investigated on trial? You know, what stood out for you on that front?
Well, one of I think the talk that I enjoyed the most wasn't about it's about a line of approach to drugs that might be there in the future. And this perhaps apply more to people with type 2 diabetes and type 1. And that was about brown fat. Did you hear anything about the brown fat when you were there, Manny?
I did not. I would love to hear from you.
Okay, so we know that many of us are covered with fat. You know, we carry it in our bellies and various parts of our body. And if you look at this, if you cut people open and look at it, it's sort of yellowish, but under a microscope it looks white when you look at the fat that's inside the cells. If you look at rodents, say mice and rats and squirrels, things like that, they also, in addition to a white fat, they have something that's called brown fat. And brown fat is often up around your neck, along here in your back, and in those animals. And it is a really metabolically active fat. It generates heat. So it's one of the ways that these animals stay warm. And when babies are born, they actually have brown fat in them, but again, around these areas in the body. And you've had babies, yes, Manny?
I have one. He's no longer a baby, but I have
Yes.
I had one.
Remember, when your baby was small and you would hold them, they'd be so warm?
Mm-hmm.
Well, part of that is because they generate heat through this brown fat, especially when they're really small. That's how they keep their body temperature up when they're so small. So this brown fat burns up calories to generate heat and energy. And people had thought that as babies grew, that it quickly went away. But now they've found that even older people have small amounts of it, women more than men. And what's interesting about this is if you take a couple ounces of brown fat, if you can get that activated, it can burn maybe 200, 300 calories a day.
Wow.
And that can have a huge effect on controlling people's weight, but also in burning up those calories, it could lower glucose.
Yeah.
And they found that some ways to activate it. One way is to be in the cold. So if they put people in a cold room or have them wear vests that have like ice packs in, they activate the brown fat and people actually start to burn more energy. And actually, one interesting thing this brings up is that people wonder why we have so much more type 2 diabetes today than we have in the past. And we usually think it's because our food choices are much worse and we don't exercise. But another fact is everybody's much warmer than they were in the past.
Global warming?
Well, not global warming, our houses. So for instance,
you mean our own temperatures, body temperatures?
No, not our body temperatures, the temperatures where we live.
Mm-hmm.
So in the past, for instance, in England, in the winter, in the 1950s, the average home temperature in the winter was under 60. People kept their houses colder. They had to have fireplaces, they had lots of blankets. People would wear sweaters. In the winter, you were just always a little colder. Now, people's homes are in the 70s the year round. So that this exposure to the cold, which many people, live, apart from the equator, were experiencing, is gone, and that could have an effect upon what we do. Well, anyway, to go back to this talk that I mentioned, there's a researcher here, actually right across the street from the Joslin, who discovered that brown fat is sort of related to muscle, and he's found ways to turn muscle and white fat into brown fat in animals and in cells and culture. So there's a possibility that we could make ourselves become metabolically more active, more efficient. And in people with type 2 diabetes, that means that being metabolically more active means you burn up more glucose, which could lower the glucose. And burning up some more calories could help the problem that so many people have with consuming too many calories or being too efficient with how they consume calories.
Mm-hmm.
And even in people with type 1 diabetes, that could be an additional way maybe to help them control their glucose a little better. But this is a whole new area of research which has developed really just over the last 4 years. It was hardly there at all before. And it's really striking. And that's something that could move quickly into the clinical field. Quickly might mean 5 or 6 years, but that was one of the things people were talking about. Well, 5 or 6 years, we discovered insulin, 90 years ago, so 5 or 6 years is still reasonably active.
Did any talks you attended or heard of touch on the topic of, this is something that's been in a few publications, and the topic of the gut flora, all the bacteria, and
Yes. Yeah. Oh, good point. It's really striking to think about it. So we think of ourselves as, I'm a human and I'm walking around doing what I want to, and I happen to have in my gut, in my bowel, I know there's some bacteria there. Actually, there's 10 or 100 times more bacteria in our body than we have cells in our body.
Wow.
And if you look, so you could look at it, the bacteria are who's here. And they're using us as sort of robots to walk them around and get them places. Because there's many more of them than there are cells in our body.
We are outnumbered.
Yes, we're outnumbered. And not only that, but if you look at the DNA, they have more genes are present in bacteria than are involved in our body, partly because there's so many different kinds of bacteria there. And this really is striking. And one of the reasons people are looking at it now is that researchers in science can only look at what we can measure. So one of my favorite cartoons, especially back when I was doing just all basic research, was from New York, where it sort of shows a city street corner at night, and there's a guy who looks like he's drunk on his hands and knees, and a cop asks him what he's looking for, and he says, I'm looking for my keys. He says, where did you lose them? He says, I lost them over there. He says, why are you looking here? He says, well, that's where the light is.
Yeah.
And so the thing is that researchers can only look at where the light is. They can only look at things they can see and measure. And in the past, if we wanted to say you had the crazy idea that, gee, all these bacteria in my gut might be important, like how do we find them? You'd have to get them and then try to grow them on culture dishes, and that was hard because they aren't the usual bacteria we're used to seeing. They live in unusual conditions. It was hard to grow them or count them. Now, because we've made such tremendous strides in being able to look at genes and DNA and RNA and proteins, that gives us a much better way to identify these bacteria and enumerate them. And we now have computers that can take all of this data, because you just have trillions of bacteria in your gut, and then can take this data and say, oh, here's the sort of population you have living here. And those populations of bacteria living in our gut have a really powerful effect. And they can also change a lot. Because, for instance, when we're born, when you come out of the womb, there are no bacteria in your gut. It's sterile. But very quickly you enter the world, you eat, you breathe, you roll around, and you form bacteria. And these are sort of stable subpopulations that they are trying to now measure and categorize. And they found that it's important maybe for both type 1 and type 2 diabetes. So, for instance, they found that people who develop type 1 diabetes seem to have a shift in all of these bacteria that live in their gut. And that might explain some of what changes the immune response.
Wow.
And it's the immune response that ends up triggering something that causes type 1 diabetes. And also for type 2 diabetes, there's they found that changes in the flora are also associated with whether I'm more resistant to the effects of insulin. Because all these bacteria living there are eating things that come through our gut, they're secreting things that other bacteria eat that we then absorb in our body. And it's just this whole part of ourselves that we never think of closely, and we're never able to measure and look at before. But it's one of those things that when you first hear about it, you go like, oh, right. I mean, can that really have an effect on people? But we now have enough data, so it seems like it can be effective. And some of these things you see on TV, like if you eat this yogurt, well, it has probiotics in it, will that change my bacterial flora? There might be something there. I don't know that any of these products have been proven to be effective. We might need to be to learn a lot more about how to alter them and how to change them long term. But I think that's something we'll certainly be hearing more about because there seems to be a lot there. And because we have these new ways in which we can look at that area, we're just going to find out a lot. Yeah, it's a really good point. Very interesting.
It's fascinating. It's like, there's like this entire microcosm inside of us that we have been, not necessarily paying attention to, and who knows to what degree it may have an effect on the development, potential for treatment, who knows. So, amazing. Any particular, trials that caught your attention, either like ongoing or completed?
Well, there was two big trials called the Origin study, which one looked at giving insulin to people with type 2 diabetes right at the time of diagnosis. And another arm of it was gave a type of fish oil to people, because there have been data from sort of epidemiologic studies that consuming more fish and fish oils was protective for heart disease and helped your profile of your cholesterol and fats in your body. So the impressive thing about these studies were they were really big. They involved over 10,000 people, I think over 40 countries, and they were really, really well done. It's hard to do a study that big in so many places and collect all the data and not have problems. So it was really well done, and what they showed was that for the fish oil, there wasn't any effect, which was disappointing, but at least now we know a little bit more about the effect of that. Now, that doesn't mean that eating fish isn't good. That means taking this type of fish oil, which is a combination of two types of fats, wasn't helpful for heart disease. The other trial where they started insulin at onset was impressive also because so many people were treated for so long. And one of the side pieces of information in this trial was that they really looked closely at whether taking this insulin, which was glargine insulin, or Lantus is the trade name, was there any change in cancer? Because there had been some suggestion from some reports in Europe a couple of years ago that maybe taking these newer insulins made people a little bit more likely to get cancer. And this study seemed to show pretty clearly that that was not the case, because they looked at it very carefully and they had good controls. They identified people from the beginning and followed them over time. But the other thing it showed, and again might be something for us to think about seeing people with type 2 diabetes, is that insulin right at the time of diagnosis for type 2 diabetes, people did really, 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 really well. All they took was one injection in the evening, very easy to dose, didn't have to check their glucose a lot, didn't go low. This all sounds completely unfair to anyone with type 1 diabetes, I know. But the results were really good. And what happens is people with type 2 diabetes are often scared about taking insulin. One of the reasons they're scared about it is because sometimes doctors like me have scared them. Well, yeah, so I might be coming in, you might be coming in to see me, you have type 2 diabetes, you're taking some pills, but you haven't been so careful about exercise and food, like 90% of people in the world. And I say to you, man, if you don't start eating better, I'm going to have to give you the needle. I don't want to do that. You need to start exercising more. So you do that, but eventually we know that your body makes less and less insulin with type 2 diabetes, and then you come in and I give you insulin, and that is not going to seem like a good thing to you. People with type 2 who take insulin often feel that they failed or their life will be more difficult, that they'll have more complications. But if you start it early, it can be very easy for them to take and very, very, very effective. And I hope that that makes more people think about that as a choice. Because insulin has a lot of advantages. It's a very natural drug. It's pretty safe. It doesn't have any unusual side effects that we don't know about. And so I thought that was interesting. And also, a side point of that study was that people were followed for a median of about 6.5 years. And their A1Cs during that whole time were really, really, really good. So the average A1C at the end of the study in this group was, I think it was like 6.2.
Wow.
And I think what happens is a lot of people think, they get type 2 diabetes. It's tough. Eat exercise. How am I ever really going to get good results and, lower my chance of having these diabetes problems later? And this shows that, wow, it's doable, especially if you start early. And I think that we know both the people with type 1 diabetes and people with type 2 that sometimes the most important years are the early years. Getting a good start really has benefits that can last for decades afterwards. And I hope that gives people with type 2 diabetes the understanding that, wow, I can achieve that without killing myself. It's just, making the right choices early, finding a doctor or team I can talk with and then seeing what my results are. So those were really big studies that came out looking at there. One of the things that I found interesting, and there were a lot of talks about this at the meeting, and there's been some reports, is the effect of sleep on your body's metabolism. And it's one of those things where some of the things we think about in a common sense viewpoint turn out to really be true, whereas a lot of things, we think about, like, aren't so true. Like, you see people who are drinking water all the time during the day, right?
Mm-hmm.
Yeah, so, and there's this idea you should drink like 8 glasses of water a day.
Yep.
Have you heard that?
I've heard it. I try. I don't always accomplish it, but I try.
Well, but that's not true. You don't need to drink 8 glasses of water today. That came from some sort of misinterpreted physiology. So we don't need to do that. Or people think if I drink water during the day, it'll decrease my appetite. And studies have shown that it doesn't.
How many glasses of water do we need to drink then?
You just need to drink when you're thirsty.
Okay.
There's no need to drink more or less. But if you drink water during a meal, you eat less. So not if you drink it during the day, that doesn't seem to have an effect, but if you drink it during a meal, you eat less. And, I might have predicted the other way, that it would both work, but when you do the clinical studies, they reported some of those there, it doesn't. Similarly, and again, this might go more for people with type 2 diabetes, but also for people with type 1 who are interested about controlling their glucose. Like, do you have a salad when you eat?
Yeah.
Of course, because you're eating healthy and you have everyone listening to you. Do you eat this?
No, I sometimes we have a thing next door here called, they sell the big salad, and sometimes that is the lunch. But I don't always eat salad. I should clarify. But, many times I do.
So there were some studies there that showed if you eat the salad before your meal rather than after your meal, that it has a better effect on controlling your glucose.
Before rather than after?
Before, right. So the American way rather than the European way.
I didn't know that anybody ate their salad after the meal, like a dessert.
Sometimes in Europe they tend to have it after the meal, as one of the choices. And also, they had a study, and I was just talking to one of my colleagues about this, Matt Berger, who works with me, where if you, so it sounds like you're also listening to what your mother told you about eating your vegetables with each meal.
Mm-hmm.
So they found if you ate more of your vegetables before your carbohydrates, rather than after your carbohydrates, that your glucose levels were more stable afterward.
Okay.
Even during the rest of the day. So some of these little things, when we do things during a meal, like having a soup, especially a soup that's a brothy soup, not with a lot of calories in, before a meal or a salad, both makes the glucose a little better afterwards, and they've also shown that people tend to eat a little bit less when they do that in careful ways. So these are little things, but I think that when the types of food you eat, but when you eat them are important. And for instance, fat. There were some people there talking about fat, and this is more maybe appropriate for people with type 1. So many people know it as like the pizza factor. So what happens when you have pizza on Friday night?
Oh, Dr. Jackson, we're having a question from the members in the community asking whether the thing about the salad is also true for people with type 1.
Yes, as far as weight and smoothing out the glucose is low afterward, and the vegetables especially. And the thing with the fat is, what many people have discovered is that you need to change your dosing algorithms because the fat causes an increase later on.
Mm-hmm.
So many people know that they have like pizza Friday night, that their Saturday morning glucoses are high.
Mm-hmm.
And so you can, if you have a pump, there's a way you can adjust for that, or else you can need to change your basal insulin maybe a little bit during the night when you have that. But to go back to sleep, so we found if you interrupt someone's sleep, it does two things. And they've done these experiments in people with diabetes, but it's almost more interesting they've done them in people without. So if you take young people, healthy, their glucoses are perfectly fine all the time, no matter what they eat, their weight is good, and you wake them up every 2 hours. You set an alarm clock that goes off every 2 hours, hour and a half, 2 hours, and they have to wake up enough to shut it off and go back to sleep again. So their sleep is disturbed.
Mm-hmm.
And then you measure how well insulin works in them. Their bodies become a little more resistant to insulin.
That's fascinating.
And the other thing is the length of sleep. So if people sleep for, and these numbers vary, a lot of studies look at for, say, less than 6.5 hours, so say 5 hours.
Uh-huh.
So if people sleep for a shorter period of time, and even if they do this in a week, so they've done these experiments where they take, again, often as college students who, they only let them sleep 5 hours a night, and then they measure their insulin in response to it, and their insulin resistance changes some, and they put out insulin not quite as efficiently as before. But the other thing it changes, and this makes sense when we think of when we're young, is it changes their appetite. So what they did in one of these studies was that they had the people come in, they interrupted their sleep in one group, in the other group they let sleep longer. And then in the morning, they did this for 4 or 5 days in a row. Then in the morning they said, now we're going to do a test because we want to see how this changes how fast you think. And they had them all in a room, and they did these puzzles to see how fast they could find the answers. And in the room, they had a full breakfast buffet, things that people could eat as much of as they wanted. And the real test was how much did they eat, not how did they do on the test they were taking.
Uh-huh.
And what they found was the people with the shortened sleep ate more than the people who had a longer sleep, even though they'd eaten the same amount of dinner the night before and all the food they ate the day before. So the people with shorter sleep, without thinking about it, ate more from these buffets.
So the proverbial snacking overnight, there's scientific data, to...
Yeah, and I think, we see that when we're staying up late to work on something, we get hungry, we snack.
Mm-hmm.
And whether that's our brain trying to provide more fuel to keep our mind going, because our brain uses a ton of glucose, a lot more than we think. It's the most glucose-intensive tissue in our body. And, again, it's one of those changes that I think is present in today's society compared to the past, is our sleep is shorter, it's much more often disrupted.
Yeah.
People's lives are busy, complicated, stressful. And so making sure you get at least 6.5 hours of sleep or more is really helpful. And, for people who's going to have concerns about weight, this can be a way where they can just inadvertently add on those extra calories, trying to make up for the shortened sleep.
There's someone that's asking in the chat room, why does my blood sugar tank if I nap in the afternoon and don't turn down my basal? Does it relate to what you're pointing out in any way?
So that's I'm not sure. So that's interesting. So first, it's terrific that they have that information. So it could be that when they're not sleeping, that either they're nibbling a little more or that there's enough stress in what they do so that their glucose is a little bit higher. Because sleep, your basal rate when you sleep until the early morning is usually not that much higher than during the day. We have lots of people who are in insulin pumps, and I don't think that the day basals are that much different than the night in general. So I think it just might be that they're removing themselves from stress, or maybe from some snacking that they didn't realize. It might mean that their basal is always actually too high during the afternoon. What would happen if they just fasted during that time? Would it go down the same amount? So there might be a little difference with the sleep, but I think it wouldn't be something that would happen in everyone necessarily.
Okay. A quick question that it just occurred to me. One of the initiatives you take on at Joslin is you have the 50-year medalists. So all these people who have been living, for 50 plus years, healthy nowadays, and any of these findings that you are now encountering to be confirmed through scientific data and studies, coincide with what you have been observing among these folks?
Yeah, we presented some more of that there, and I'm glad you brought up. I have a little note to myself for that. So I think first is that many, it's just realizing that they exist. So our 50-year medalists, their average age is, time with diabetes is about 66 years. So one interesting thing is if you subtract back, that means that they all were diagnosed with diabetes and taking insulin, for instance, before there were glucose meters, before there was A1C. We didn't start to measure A1C until the late 70s. So they had diabetes back in the dark ages.
Yeah.
And yet many of them do really well. And when we've looked at them, we found that almost a quarter of them or more had like zero complications, like nothing that we can see anywhere. Neuropathy, eyes, kidneys, everything is perfect. And it's not that these people have had the best glucose control, the best A1Cs, especially through their whole life. I mean, they're pretty good, but it's not that. So what that tells us, one thing is that tells us that complications are not a necessary part of having diabetes. And the other thing it tells us is that people are different. I mean, it's obvious that people are different, but their diabetes is different. Or is it something about their body that's different? So one of the things that George King, who's our research director here and is the main investigator in the study, are doing is they're seeing, like, what is the difference? At first they started looking at simple things, where the more people were left-handed, had red hair, are there genes that you can measure, biomarkers in the blood, and nothing really stuck out. Now what they've been doing are more complicated studies where they look at people who haven't had complications and they try to look at all the proteins that they can measure in their body and compare those to people who have had some complications, and then to people without diabetes, and then look for differences. Is there something these people are making that seemingly maybe protects them from getting these complications? And all I know is that they are more and more excited about what's going on at the cellular level. They haven't found anything yet that they can try in people that's there, but I think that this group can really tell us something that will help in the future. But they've already told us things for the present that help. So if you've had type 1 for 25 years or more and don't have kidney disease, it seems really unlikely that you will develop it in the future. Not zero, but not that much higher than anyone else.
Okay.
If you've gone maybe 20 years without needing laser treatment, again, that might mean that your eyes are going to really do well looking forward. And we're going to get more of that sort of information going forward. The other thing you may have heard of is that in a fair number of these people, they're still making little tiny amounts of their own insulin. And in fact, when they look at the pancreases of these individuals, because everybody we give a medal to, well, everybody, and they don't have to be patients at the Joslin. Anybody who's lived 50 years with diabetes will get a medal from us. They will also be invited, if they wanted to take part in the study, they'll fly them to Boston at our expense, put them up in a hotel, give them a little tour, and draw blood from them, poke them, take little pieces of their skin maybe. And some of those people have said that when we pass away, if that ever happens, you can look at our pancreas in our bodies. And now that we've had that happen, that we're finding that in everybody, when we look at their pancreas, they still have little amounts of insulin-producing cells there.
Wow.
Maybe not enough to have done a lot, but in the past we thought that that never really happened.
Yeah.
So what if you, Manny, got hit by a bus tomorrow, which would be terrible, right?
Yeah, I'd be very sad about that.
Body, and hopefully you've donated your body somewhere. So then we would look at your pancreas and find, gee, there's some insulin-producing cells there. Now, if we knew those were there, what if we could stimulate those somehow? And that's a whole new area of research. It's been driven partly by the fact that we know these cells exist. And when we see them, they're not always in the usual places. They're at some different places in the pancreas. Maybe those places are protected from this destruction, and maybe there's a way we can stimulate those and get them to grow. But I think these 50-year medalists are going to tell us more in the future, as well as the fact that they're telling us now that, you can do this. I think the patient we had that was on insulin the longest was on it for maybe 86 years.
Wow.
And he got it when he was really young. And he passed away, unfortunately. Not related to people. And actually, the story I'd like to tell is he did have a problem. His major problem that he had was that he wanted to go on a cruise with his girlfriend. And her children wouldn't let her because they were both over 90 and they were afraid she would slip. Fracture her hip or something. But he had really wanted to go on a cruise with her. So my point is that he had problems, but they weren't related to his diabetes. That's everybody's goal, is to just have our normal human problems, not have the diabetes add so many to them.
Absolutely.
Really, when I look over the meeting, and I have the advantage that I've been doing this I've been at Joslin for 30 years now. And I was just looking back, I used to have patients with ulcers in their feet and amputations, and I just, that's so much less common now because everybody is doing a little bit better. It's slower than it should be. It's a reminder that there's going to be progress out there.
Yeah.
And these meetings always excite me because there's always something new that I didn't quite expect that someday might have an impact on helping everybody out.
Few questions from the chat room. Someone was prompted to ask when you were talking about residual insulin production in some of the pancreases of these long time people with type 1, whether you guys have done any work with Dr. Faustman at all?
No, so Dr. Faustman had a similar report. She's located about 4 miles down the river from us. But we were already looking at that beforehand, so I think that we're, sort of well ahead of the game in that aspect. But it's something that other people will find too, if they, look at these populations.
And we're getting a question in regards to degludec. I mean, there has been quite a lot of talk, and there was some at the meeting about degludec. Is it as effective as it's being claimed? And what do you anticipate or expect from degludec down the road? When and if it clears, FDA.
Yeah. So I think the main thing is it's always good to have more choices. So degludec is insulin made by Novo that's longer. It has two attributes that they're promoting. The one that's clear is that it has a longer duration of action than NPH, Lantus, or Levemir insulin do. And the other thing is that they feel it has less variability, so it'll provide a more stable basal rate. And I think it would be great if that were the case, but I think that if it is a little better than the current basal insulins, it's just going to be a small amount better. It's not going to make a big difference. But again, to have another choice is helpful. Uh, what I hope is that they would make it less expensive, so that it was so available to more people around the country and around the world. Uh, but again, it's going to make a little difference, but it won't be a big splash.
So it seems, on the very long-acting insulin front, there's perspectives on the very rapid-acting insulin fronts. There's need for more progress to be made. So, there, we're about to run out of time. There's like a couple more questions I'd like to get to.
Okay.
One was asked by a member in connection with the announcement we made that you would be talking to the community, and it's a little more unrelated to ADA, but more with your area of specialty. This member said, "I wish I had known that Jake was susceptible to insulin-dependent diabetes. His diagnosis was a surprise. No child in my family has ever had insulin-dependent diabetes. My other sons are in the TrialNet study. My father's brother was diagnosed with, quote, shock diabetes in his late 30s, maybe late 1950 to 1960, after causing a vehicular pedestrian homicide and receiving multiple phone calls, etc., about his fault, on top of his innate guilt. How is immunobiology involved with the lineage, aka why Jake exactly?" It's a
Yeah. Well, that's a good question, because when anything happens to our children, we wonder why. And so we know that type 1 diabetes is a genetic disease, but there's other components too. So if I have type 1 and I have an identical twin, his chance of developing type 1 is somewhere between 1 in 3 and 1 in 2. So it's not 100% that having all my genes means he gets it, but it's much higher than the general population where it might be 1 in 200. So if we know it's genetic, why does it seem that there so often is not a family history? Because only 15% of people, when they develop diabetes, have a close relative with it, whereas with type 2, it's much more common. And the reason is that there's multiple genes involved with type 1. Some of them you may need to have 2 copies of them. And so with these multiple genes involved, if you sort of do the math and then say, even if I get all the genes, I'm going to get diabetes a third of the time, then it turns out that for 7 out of 8 people that get, or I guess really probably 5 out of 6 people get type 1 diabetes, it just comes out of the blue. It is genetic, but it's just how those numbers turn out. It does mean that his brothers are a little more likely to get diabetes, but their chance is like 1 in 20. So still low, but higher than the other population. And so the reason that the numbers turn out that way is because there's a number of genes involved. It's not like Huntington's disease or cystic fibrosis or sickle cell anemia where there's a single gene. You have a problem with that gene, I get the disease, and I can pass that on to my relatives or not. Here it's more complicated, so that's what the numbers are.
Okay. So the final question we get, because we're about to run out of time, and it's a very easy one. You probably won't have any problem in addressing, in a short amount of time. One of the people in the chat room are asking, in your opinion, what's the next research breakthrough going to be?
Oh, yes. I don't know. It could be, a really accurate continuous monitor. Stem cells, there's always a lot going on there, and it's still not even working in animals, but it's an area which could take off very quickly so that you could grow some of your own insulin-producing cells back, or you could convert some other cells in your body into insulin-producing cells. But when people ask me about what's the most exciting thing, to me the most exciting thing is the fact that when you look at recent data, people with diabetes, their complication rates decreasing faster and their lifespan is increasing faster than researchers can really explain. So between 1999 and 2006, there was a 40% drop in mortality in people with diabetes. So now, if you look at people with diabetes in the country, they're not quite as likely to live as long as life as people without diabetes, but that's if you look at everybody with diabetes in the country. If you look at people with diabetes, like I bet most of the people listening to this podcast, or what we're calling it, is that if you are engaged with your diabetes
Yes.
and control your blood pressure, control your cholesterol, your A1C is not terrible. I think for the A1C, it's more important that it not be bad or terrible than it be really good. But then your chances of living a long and healthy life are just about the same as mine, and I don't have diabetes. So that's been slow and incremental, and I think that news will get out more, except for the fact that there's so many people who aren't engaged with their diabetes that if the CDC and the NIH said, wow, people are living longer than ever, that's not a message they want to get. There's so much to be done, and so many people who need to become engaged with their diabetes. So they make it sound like diabetes is getting worse and worse. And it's true that more people are getting it, but people who have it are really doing better than ever. And that's what everybody listening here should know. We just wish it were much easier. And I think that that's really part of the research, is to make it easier to reach that goal of a long and healthy life. And I think, that most of the people listening are young enough and things are moving fast enough that they'll be able to take advantage of something that's not available now.
Phenomenal. I think there couldn't be a better way to wrap up this session today. We're extremely thankful for your time today. You're an extremely busy person, so we really appreciate you making the time to speak with the community. We hope to have you with us again in the not so distant future.
I'm happy to do it. Thanks.
Thank you.
Thanks, Abraham. Bye-bye.